Hello, everyone. So, as said Steve, thank you for the nice introduction. I'm in charge of the mobile services for Orange International Carriers and working for Wi-Fi in all the mobile. So today we will speak about the convergence between the Wi-Fi networks and the mobile networks, especially for the roaming and for both data and voice. So today, what is clear is that a smartphone is a predominant media, and most usage is now in data. So some figures, we are touching our smartphone more than 200 times a day. And the voice usage is only the fourth usage popular on your smartphone. So you are doing anything else on your smartphone today than just placing a call. So it's more a smart device than a smartphone. But if you want to have a good user journey, it must be simple. It must be also consistent, and it should hide the underlying technology. The end user doesn't care about its Wi-Fi, its mobile, its whatever, it's unlicensed, licensed. They don't care. They just want to have something out of the box, working well, with absolutely no worries. So this is where we can have a licensed spectrum meeting the licensed spectrum, because today, if you are enjoying your device in the mobile area, when you are using a mobile, it works pretty well without doing any configuration, any settings. But when you want to use Wi-Fi, it could be from an easy user experience to a complete nightmare in some situation. So we have to bring the two technology together. So we did a lot of work with Passpoint, Hotspot 2.0, in WBA, with the whole industry to make things simpler. So what we did, the simplicity. By having a SIM authentication, it's more simple to connect to Wi-Fi. Imagine you are enjoying the WBA NGH SSID here, and you are using a simple connectivity thanks to your SIM card. So you don't have to remind or to enter any information, username and password. So this is the first step we did with Passpoint and Hotspot 2.0. After, about the security. Wi-Fi is known to be not so secure as mobile also, but with Passpoint, we added a security layer to the network, and we are able to cipher the network and to be sure that even the radio link is as safe as for mobile. Next point is about the completion. We used to use Wi-Fi for data, and now thanks to Wi-Fi calling, we are also able to use Wi-Fi for voice in a simpler way. So you have all the services both on mobile and Wi-Fi. For the quality, Wi-Fi is no carrier grade. You are able to provide a good quality on Wi-Fi, and we are also able to improve the user experience and the quality, especially in indoor environment. Because if, for instance, in this room, everybody was using a 4G, we will have some issue with the network congestion. But thanks to Wi-Fi, we can help to carry all the bandwidth needed. And the last one is about savings, because Wi-Fi is known as a cheaper technology than mobile, especially because it's unlicensed, and you don't have to invest in huge license to make it work. So you have some savings. But there is a remaining point. It's about roaming. Today, the roaming end user end-to-end experience is different between Wi-Fi and between the mobile. There are still discrepancy between the two models. So just as a reminder, when you do Wi-Fi roaming, the way it works, even with Hotspot 2.0 and SIM authentication, is that you are connected to a network, a Wi-Fi network. You are authenticated with your own providers because you are doing roaming, but your traffic is still local blackout by the Wi-Fi provider. So what does it mean? It means that, for instance, if you are roaming in China, if you are using Wi-Fi in China, you cannot access Facebook because of the policy of the Wi-Fi provider. You cannot access this kind of services. But if you do roaming in mobile, because of the architecture is completely different, you can still access to all the services and all the content you used to have access at home. Because when you are doing mobile roaming, all the traffic is encoded to the home network and is bring back to the home network, and then you exit to the internet. So it means that, for instance, when I'm roaming here in the US, in Wi-Fi, I've got a US IP address. So I have a limited access to my content and my French content, for instance. But if I do a mobile roaming, I still have access to my French content. And especially from a mobile operator's point of view, if you have some specific services, like mobile TV, like cloud, whatever, you only provide it to users who are registered on the trusted side of the network. So you can provide it in roaming on mobile, but you can't provide it on Wi-Fi. So in that case, the home mobile provider is only able to provide internet access on top of Wi-Fi and not a complete user experience. So as an end user, you don't understand that. Why, when I'm on Wi-Fi, I can watch my mobile TV, for instance. On mobile, I can watch my mobile TV, and when I switch to Wi-Fi, I can't. So the user experience is not similar between the two. So what's missing to close the gap? So it's just a wing to just a factual wing. In 1969, we went to the moon with a computer which is only 1 megahertz. It was really a success with a very, very low computing capabilities. Now we are in 2016. We have in our pocket, each of us, one computer far more powerful than the Apollo 1. We have some artificial intelligence. We are able to speak with our smartphone. But this smartphone is not smart enough to connect us easily to the networks. So just to say that it's definitely not a technology issue. We have all the technology bricks to do it. It's just a question of willingness. Do we really want to merge the two networks and to make them convergent? It's a question of willingness and a question of business model. There is absolutely no technology blocking point to make this happen. So now what we are doing in Orange Carrier, we are proposing a model to close the gap between the two technologies. The idea is to propose an end-to-end user roaming experience. So let's open the border between mobile and Wi-Fi by duplicate the mobile world with a mobile core and coverage for Wi-Fi data roaming. So it means that all the data, even in Wi-Fi, will be brought back to the home operators, relying on carrier-grade Wi-Fi network. What is really important in this, for that, we don't want to rely on free Wi-Fi you can find in a location with username and password, which are not secure enough, which are not quality carrier grade, and which are not providing the same quality as that you can expect when you roam on a mobile network. So we are just addressing the carrier grade kind of network, so hotspot 2.0 and passpoint network, not the legacy Wi-Fi, whisper kind of Wi-Fi. And the idea is to reproduce the architecture from 3GPP in 3G and 4G to the Wi-Fi. It means that we are able to bring all the traffic from a carrier-grade Wi-Fi back to the home network. And what is really interesting is that for the home network, whatever the kind of radio you are roaming on, this is the same processes. This is the same way to connect. This is the same technology. The home network doesn't have to put some dedicated resources to manage the Wi-Fi roaming. So thanks to this simplicity, we strongly believe that we will leverage the adoption of Wi-Fi in roaming by end users and not only on a free way as you know today. So how does it work? As I told you, it's not a technology matters. We have the technology. We did a proof of concept, and we are able to do it. It works now. When you have carrier-grade Wi-Fi, first you have to manage your authentication. So the authentication is managed thanks to your SIM card authentication sent to a AAA server we are hosting in the cloud, and we are able to do the translation between the radius, which is a standard and Wi-Fi, to the mobile standards, which are SS7 or diameter. So we do this translation, and it works already. The second point is that when you are in mobile, you are bringing all the traffic, data traffic back to the home using an IPX network, and you have to set up a GTP tunnel on top. This is the architecture of the 3GPP. So if we want to hide the fact that we are in Wi-Fi at the other point of the data link, we have to reproduce this. So for this, we are using a TWAG. It could be a TWAG hosted in the carrier-grade Wi-Fi, but it could also be a TWAG hosted in the Orange IPX, and we can do all the traffic back in this GTP tunnel. Then you can deliver the internet access, but from your home. It means that you will have a home IP address, the same user experience between mobile and Wi-Fi. And the last point is that thanks to our roaming hub, we have a roaming hub addressing 2G, 3G, 4G, and Wi-Fi. We can speed up the connectivity. We can connect more operators, because today, thanks to our IPX, we have an A-to-Z footprint. We have more than 200 ports to address the connectivity, and more than 100 mobile operators already connected to the hub. So it's not just a Wi-Fi hub, Wi-Fi to Wi-Fi, it's really how to merge the mobile side to the Wi-Fi side and speed up the connectivity and the adoption. So it's a complete and seamless solution, SIM-based. The device automatically switches from one to the other one, and you have a new roaming agreement set in place easily thanks to the hub. And what is really important is the mobile roaming processes. Today, when you are an operator, you don't want to have multiple processes, multiple resources, multiple people for each technology you want to do roaming. You want to have something consistent between it. And as long as you don't have this, you will not develop massively the Wi-Fi roaming. So the other point is its benefits for the whole value chain. So first, you have a benefit for the Wi-Fi provider, because thanks to that, you can increase the inbound roaming. Because it's simple, you have all users who can move from the mobile to the Wi-Fi, so you will increase the inbound roaming. So for the Wi-Fi provider, it's a way to have a better monetization of its network, so to sustain the investment and to develop its network. It's easy to implement because following the standard, you just have to get an IPX connectivity and reduce the interconnect. For the mobile operator, no. It's a way to address the silent roamers. Most of users, when they are traveling, which are not B2B users, stay in airplane mode when they are traveling because they are afraid of bill shock. So thanks to this solution, you can better target the silent roamers. You have a user experience improvement, as already described. You have the same experience between the two, so your end users are happy to have the same user experience, and you can do savings on the outbound roaming. So we'll come back to that point later, because it's important what the mobile operators are expecting while doing Wi-Fi roaming. It's having a cheaper IoT to be able to provide more to their end users. And finally, for the end users, you can roam like home for the end user, simplicity and security and better indoor coverage. So this is the point. All you can eat roaming is the future. Today, when you roam, you pay per megabyte, you pay per minute, but it will no more be the case in a few years. Because what happens is that users want to roam like home. You have a regulation pressure. For instance, in Europe, you have a roaming-free agreement saying that no more roaming charge for the retail between European countries. But you still have to provide it. So what will happen is that the retail pricing will not remain per megabyte. It will be a bundle with your data plan. When you will choose your data plan with an operator, you will choose the one who proposes you the best roaming experience and the best roaming price. So the user will select provider following this roaming experience. It's a real opportunity for Wi-Fi to monetize. And mobile operators, once you move from per megabyte to unlimited or included roaming, they will look after savings on outbound roaming. And this is where it will be interesting to address these Wi-Fi operators. So quickly as a reminder, it's integrated in a complete roaming solution by Orange because we are already addressing the signaling, already addressing the diameter, already addressing SS7, roaming hub, messaging, IPX. So it's not just an offer of Wi-Fi, it's a complete brick in a global solution. So as I told you, we did a proof of concept. So we have a demo. We can see the demo in the innovation lounge right after during the break to see how it works when moving from one network to another one. So we reproduce a 4G network here and a dedicated Wi-Fi network with an IPX connectivity. And I would like to thank the partners who helped us to do this demo. So we worked with Boingo for the hotspot part, with Cavium for the 4G, and Arfern, Hewlett, and Acuris for the AAA. So we were never so close. Thank you very much.
We have questions coming in fast and thick. I will take two very quick questions, so if you could put them on the screen, we'd be very grateful. Okay. What GTP exactly was? So could you explain GTP?
Yeah. GTP is a GTP tunnel. In fact, it's a tunneling protocol. When you connect a visitor network to a home network through an IPX, which is an extranet, an MPLS network global between all the operators, you have a GTP tunnel which is set up between the device and the core network. So if you just connect an IP, it's not enough. if you want to reproduce the 3GPP architecture, you have to present every traffic into a GTP tunnel. So this is why you have to set up a GTP tunnel for each connection of device when you do a Wi-Fi roaming this way.
Okay. You talked a lot about the commercialization, which is great. And there's a question saying, will there be a revenue share with the MNO who provides the SIM?
Will there be a revenue share with the MNO who provides the SIM? So the way it works, it's a traditional roaming. So it means that the MNO who provides the SIM will pay IoTs, megabyte IoTs to the Wi-Fi provider. But at a cheaper price than a mobile, if we wanted to make it work, it must be cheaper than a traditional mobile IoT. But it's a traditional wholesale agreement. So you pay for IoT just to use the network. The only difference is that for the Wi-Fi provider, it's just an inbound revenues. So it's not a bilateral because the Wi-Fi provider has no users to send to the respective mobile network. So it's just a one-way roaming agreement. Right. But it's a roaming agreement which allows the MNO to reduce its wholesale cost, especially interesting when you bundle it and an integrated offer on the retail side.
So I imagine that the operator who's taking the money for the customer, who's got a data roaming agreement for 4G, 3G, and Wi-Fi, a share of the revenue they take on that bundle will be just exchanged through the normal
IoT.
Wholesale agreement.
Normal wholesale agreement. The wholesale model in the middle is still by IoT per minute or per megabyte. Yeah. And the roaming hub we provide is able to do one single bill to any networks for any technologies, and we provide the one single bill to the MNO for all his roaming agreements to speed up the adoption.
That's terrific. Thank you very much, Cedric, for sharing that.